within the traditional factors, which is air pollution. I want also to thank very especially to Francesco Caola and Parla and all the department, Lazio people, for inviting me to co-chair this session and to be part of the meeting. I think that there is, if you look back to the last 30 years, there is no doubt that air pollution epidemiology has been a driver for the development of environmental epidemiology. And air pollution still is doing that, so this is a very good topic for a plenary session like this. And I cannot see a better speaker as Professor Annette Peters. Professor Annette Peters, who many of you know, is head of the Institute of Epidemiology at Helmholtz in Munich, and it's also PI of the CORA cohort in Germany, and sits at the advisory board of directors of the German national cohorts. Annette has made pioneering contributions in the 90s during air pollution episodes and looking for initiators of myocardial infarction with well-known papers in Lancet and New England, and has continued recently doing more complex studies on genetic and epigenetically mediated effects. And I think that her update will provide a wonderful way to contribute to the starting of this meeting. Thank you so much, Annette. The floor is yours.
Thank you very much for the kind introduction and also for the invitation to speak here about what we know about health effects of air pollution and what we should know. Before I start, I would like to declare conflict of interest in this respect that I have been funded by various national and international grants to look at air pollution health effects as well as chronic disease epidemiology. And actually it was thought, as pointed out, that the major episodes would have been over in Europe in the last century. However, we are still seeing effects to date, and we have an emerging problem of air pollution, or still very virulent problem of air pollution around the world. And so the overall take-home message of my talk is that air pollution affects multiple organs. This is why it's so important. It's not just the respiratory tract where we inhale particles and gases. It's also the cardiovascular system, it's the circulation, there is the reproductive system which is impaired, and there is the effects on the brain. And it has immediate effects, so it can trigger events, but it has also much more important long-term consequences and can contribute to the etiology of disease. So given that this is such a wild field, it was a real challenge to select topics to talk about what we know. So I will talk about air pollution as I see it and salient aspects of air pollution we know about and we need to consider. I will talk about long-term health effects for mortality because I think these are still driving legislation and we have a major problem there still in Europe and in other parts of the world. And I will take the cardiovascular disease as an example of how we can assess immediate as well as long-term consequences. So to start off, ambient aerosols are gases and primary particles mostly emitted by combustion sources. And while we are talking a lot about traffic, there's also the industrial sources and there's the home heating area. There are organic compounds released into the air. We have soot particles, we have metals on the particles. We have the secondary particles, so particles which are formed either from organic precessors or inorganic gases, but we have also resuspended soil and biological materials. And for the particles, it's really the size which matters. We classify them as thoracic, so being able to enter the lung if they are smaller than 10 micrometer in diameter. If they're smaller than 2.5 micrometer in diameter, they reach down into the air sacs, into the alveoli, And then we also have the ultrafine particles, which are also called nanoparticles, which are smaller than 100 nanometers, are in the range of molecules, and have special properties, as I will explain to you. But these particles are actually not chemically all the same. They come with different materials, such as the carbonaceous particles or the black soot particles. They have secondary organics, which have been potentially are activated. We have the secondary inorganics, we have the coarse particles, and then we have these very fine, ultra-fine particles, which you see up here, which have little mass but are there in high number. And most importantly, they never are by themselves, and they never are just one kind of chemical if you have them in an urban setting. So they are always mixed, as suggested here, and you can consider that these are spheres which combined and they accumulate further material on. So if we think of particles and their health effects, while we are discerning sources, we are always assessing them together. And the size really is what matters where they are deposited. So in the upper airways, which you have here, it's the larger particles which are depicted there, but it's also the ultrafine particles which can be there. And then it's the fine particles which reach down into the alveolus, where there is actually no active transport out of there, but the immune system which can transport the particles out. And so if you look further into the lung, it actually turns out that these different sizes of particles do reflect differently on the bronchial epithelium, as you see it here, and to an alveolar macrophage. And you may consider that this immune cell is very able of engulfing these two kinds of particles, but it has a hard time to really finding the small guys. And the small guys are as large as a molecule, and they actually can, by diffusion, enter cells and enter into the bloodstream, which makes the particles being able to induce oxidative stress because they can catalyze reaction and generate oxygen radicals. They activate the immune system because the immune system recognizes, and it's the only way of particles out of the alveolar space. If they are ultrafine, they actually can translocate because they diffuse, and then they have effects in the circulation and potentially also inflammatory response in the brain, and other organs and tissues. So with that in mind, I would like to revisit some salient studies which have moved forward our understanding and our abatement of air pollution. And actually, much of the work which is driving regulation all over the world is from the United States. And here you see the map showing that there are different regions with different contamination. This is the 2000 map, which highlights the industrial areas in the east and the Los Angeles basin as being highly polluted. And it's due to the first evidence provided by Douglas Dockery, who was able to show in the Harvard Six City study that, yes, you can see the long-term health effects by this study being specifically dedicated to show the air pollution health effects. The second study, which has been very influential in terms of regulation, is the American Cancer Society study and the analyses headed by Arden Pope. And here you see the exposure response function for fine particles going from little below 10 microgram per cubic meter up to 25 or not even 25 microgram per cubic meter. And you see the current recommendation of the WHO, which dates back to 2005. You see the US EPA standard, which is actually close to it. And you see also the EU limit value for fine particles, which is way off, which is even not on the dose response function. And there is an imminent need to really act and improve the standard setting in Europe. Because from studies from Canada, we know that even below the current WHO guideline of 10 microgram per cubic meter fine particles, there is still a linear relationship, as you can see there. And there is now big endeavors going on to combine data from the US and Europe to really find out about the exposure response function at these lower levels. For Europe, we had the ESCAPE project, which was able to show, yes, there is an increased risk of 7% per 5 microgram per cubic meter fine particles on total mortality. And if you compare this with the American Cancer Society study, the risk is actually twice as large. And this is now work from Rome, where Francesco and his colleagues, led by Julia, were able to not only assess the particles, but also have models in hand for NO2 concentrations, and they were able for the first time to show that there are independent effects of nitrogen oxides and particles on mortality. And this paper, I think, is really important in the current light of the discussion of the problems of the German car manufacturers having not kept the limits of the NO2 concentrations and the rising concentrations we face in our cities. And so with that, we have ample evidence that the fine particles and the gaseous pollutants are contributing to our burden of disease. And this was just an exercise I did with the burden of disease, global burden of disease tool, to assess the relevance of air pollution for Germany, which is not a highly polluted country per se, and which made clear that ambient air pollution is really among other important risk factors for mortality. So with that, I would like to move into talking about how air pollution can elicit health effects and what are salient features of that. And I will take myocardial infarction as an example because it's actually a distant disease. You inhale the particles into the lung, but then how can it impact the heart? And it's actually not just the overall impact on the heart which is relevant, but it's a rupture of a plaque which is in the coronary artery and the occlusion of the artery for more than 20 minutes, which really make this severe event happen. And so there has been substantial work in disentangling the mechanisms behind that, and this is this review paper from 2010, which highlights 3 major mechanisms, one of which is the link of the particles to inflammation, so which I have described to you in the previous session already. There's also a link of the particles to the autonomic nervous system, and mainly potentially through irritant receptors in the upper airways. So it's, and then there is the link that actually the circulation can be impacted, direct effects on the heart cells, on the blood cells, and so forth. And if you now think back when I was describing the particles to you, so you have these larger guys and you have the smaller guys. They actually reach different areas of the lungs, and then they start to trigger these different responses. They do a little bit of inflammation in the air sacs. They activate the irritant receptors in the upper airways, and then a few of them, or the constituents they carry into, reach the bloodstream and kind of are able to interfere with disease processes there. And if you take this together, it's not just that this is happening kind of all at once, but it also has different responses. So if you have an activation of the autonomic nervous system, it's actually a very rapid response. So it's the particles which land on the upper airways, they can elicit something quite quickly. And then the controlled human exposure studies have worked out that for reaching these endothelial and vascular effects, you need a couple of hours, but it's also rather immediate. And then you have the inflammatory responses, which due to their nature actually need activation of the whole cascades, including the liver, so that needs a day or so. So it's while we are constantly breathing these particles, the responses of our body are on different time scales, but they all kind of amount to potentially severe events. and that severe events are possible. We have shown when we assessed air pollution as a potential trigger for myocardial infarction, and found as a surprise at the time in our data that people who had an onset of MI were 3 times more likely to spend time in traffic than in other periods in the previous 4 days. And this was a finding we could observe consistently by different modes of transportation. And in 2007, Nick Mills, together with the colleagues in Umeå, was actually able to demonstrate in men with coronary artery disease that upon diesel exhaust exposure, there were signs of ischemia detected in the electrocardiograms of the subject, and this was happening within 15 minutes. And we have followed up this further, equipping volunteers with personal monitoring for ultrafine particles, showing that yes, indeed, elevated exposure in microenvironments can alter the autonomic function within 5 minutes. So it's this immediate effect. However, if this was happening on a day with high fine particle pollution at the central monitoring site, this also increased the autonomic nervous system response. So you have indeed this combination, and some of these effects are really independent because it depends on the exposure pattern, and they also act through different pathways of the cardiovascular system. And then it's these short-term consequences which we have, but we have also the long-term consequences potentially being initiated through inflammatory processes. And there's animal work. It was actually work initiated by Nino Künzli looking at intermediate thickness, and it was followed up in the Los Angeles area by animal work, which showed that upon exposure of mutant mice with a high-fat diet and being exposed either to fine particles or ultrafine particles, they could show lipid accumulation and progression of atherosclerosis in these mice. So where do we stand today in this? And I think a recent paper by Joel Kaufman et al. Showed very nicely that upon high exposure to fine particles, there is indeed a progression of atherosclerosis here measured by a coronary artery calcification score. So taken together, we have actually a paradigm which accommodates events which go from very immediate action of particles, triggering an event in somebody who might not have had the event otherwise, to a contribution to a long-term progression of underlying disease. And with that, I'm moving into what we should know. And I think one of the important things is we should really understand the systemic impact of air pollution. So going back to my first slide, we now have evidence for many outcomes which actually will substantially change the assessment of the burden of disease of air pollution. And we have actually started out when we did the research by looking at the respiratory system and the cardiovascular system, and both of which have immediate responses to air pollution, in addition to the chronic responses. But now we are also finding effects of air pollutants in organ systems for which we do not have a readout for the immediate response. So we find changes in metabolism, we find changes in skin, we find the changes in the reproductive tract, and potentially in cognition and neurodegeneration. So I think this is a paradigm. We started out with diseases where we had both acute and chronic effects, and we are now really moving into understanding the overall systemic effects, including other chronic diseases. And I think for that is also the understanding important that the air pollution does not impact our bodies by itself, so that overnutrition, which is a rising public health concern, is actually helping to promote these potential deleterious effects in the body, and that there is multi-organ involvement, and underlying this is the notion that inflammation and oxidative stress is part of the major pathways. And especially the neurological and psychiatric conditions are an emerging field. We will hear a lot, I think, during the conference on new evidence. And we have both in children and adults tentatively associated health effects. And we are also now looking at different biomarkers or biomarkers of effects to study these. The second area, which I think is important, is to exploit the biomedical advances. And there was the idea that we could assess the exposome as we could assess the genome. Well, the genome was thought to be easy. Nowadays we know it's much more complex, but I think it's a good idea to comprehensively assess the exogenous and endogenous exposures. And the companies who are selling these novel technologies, they kind of would like to draw a picture like that with the old targeted biochemical analyses, you had a blurred picture. And now with the unbiased, untargeted approaches, we get a clear picture. Well, we know that there is still some way to go. And I think there's also now good understanding in our community that we need to link the traditional ways of exposure assessment together with the new ways. Nevertheless, I think that they offer a tremendous potential to use the epigenetic modification, to use biomarkers, to use metabolomics, and the emerging information on immune cells together to really understand early disease development as well as healthy aging. However, also this is going to have surprises. We just a couple of months ago published our first genome-wide methylation study looking at methylation sites in the whole genome in association with fine particles based on the CORA study and the normative aging study. And we actually initially thought we would easily detect long-term exposure and methylation changes because epigenetics was thought to be the constant part of regulation. It turned out that this was wrong. We actually found the most impact for a 28-day moving average and differential methylation site. And I would like to draw your attention that this is the Bonferroni corrected limit. And down in the blue line is the false positive discovery rate. So there is a big difference between these. And I think there is still a lot of need to work out what this really means and how we actually also analytically approach this.
3 minutes, Annette.
And then the comprehensive assessment of urban environments is my last point. In the ReviHub report, we highlighted that we need more evidence for the long-term exposures to a number of particles measures as well as the gaseous pollutants in order to move regulatory processes forward. And I just would like to highlight the work from Bart Ostrow because he was actually the first to show in the California Teachers association between ultrafine particles modeled in the area and cardiovascular disease mortality. And in 2 pollutant models, the ultrafines even seem to have stronger effects, something we really desperately need more data on. And then it's really air pollution has been well recognized to be not on its own. Noise, temperature, and green spaces are impacting on the environmental side, but at the same time there is behavior, lifestyle, and the socioeconomic context which substantially alters the associations. And just as a final closure, 3 more areas which I consider to be salient. One is that we will be seeing new technologies such as e-mobility or energy efficient cities, which actually will completely change the air pollution mix and will lead to a revival of old sources of air pollution. We have aging societies, we have migration, and especially in many places around the world, we have lifestyle and socioeconomic changes, which again will lead to a different susceptibility, different vulnerability, and different co-exposures. And then last but not least, an area where I personally have not done much research myself, it's the life course assessment and the translational impacts of ambient air pollution, which I think will be where we need much more information, and which again will revolutionize our understanding of the health effects of ambient air pollution. Thank you very much.
So thank you very much, Annette, for this excellent review and update. And now we have just a bit of time for 2 short questions. Please remember that you have the microphones and present yourself before making a question. No?
Yes. Yeah. At the top.
Okay.
Hi, Colin Soskolny. Thanks very much, Annette. My question relates to how particles might be used to carry as vehicles toxicants to the inner air spaces. Could you comment on that, please?
Yes, so the particles have large surfaces, especially the smaller ones, and we know that they can carry toxicants. It's just that it's very difficult to provide assessments of these toxicants on the particles, but it's definitely one consideration, and I would personally argue that especially if you have open pit waste burning and issues like that, this might be much more potent than we have been seeing these effects in Europe and in the United States. And some of the work of Beate Ritz on pesticides is, I think, also suggestion that actually these pesticides are associated to particles, and that's how they reach the body and are an important part of delivering this exposure.
Okay. I have one question, and it's because you make a very strong case that there are very wide number of outcomes that are related to air pollution. Some of them are still not seriously investigated. And do you think that there is a room for studies focusing on specific groups of multimorbidity?
Yes, I think as the societies age, multimorbidity is becoming much more and more an issue, and we have started to look at this, and we'll have a session on aging and the environment tomorrow. And I think that actually, and then when we combine, for example, cardiometabolic diseases, we see larger relative risk than for the individual diseases themselves. And to me, that makes sense because the mechanisms I was describing actually promote cardiovascular disease, but the inflammation potentially in the fat tissue also promotes diabetes. And if the particles are really also reaching the pancreas, potentially they can also elicit effects there, which we simply have not really been quantifying so far.
Thank you very much. So we are now short of time. We need to close the session here. First, we applaud Annette for brilliant presentation. And just a couple of words to close the session. I think that was a great idea to start with the traditional risk factors, because probably both presentations remind us 3 issues that we need to keep in mind during the Congress. One is the traditional factors still are very relevant and frequently still dominate the agenda. So we are accumulating risk factors rather than removing risk factors from our societies. Second one, and there is a reason for hope, I think we are now better equipped to, as epidemiologists, design studies and understand effects. We have seen this from Pier Paolo's presentation and from Annette Peters' presentation. The third of one, it reminds us the importance of interventions and policy, and this is the main goal of what we do. And probably, and this is an issue that it will be focused in several sessions here in the program, we are now in a time where new avenues for translation are developing. We have the Sustainable Development Goals at the very international level. We have the planetary health concepts being put forward by several fields. We have a clearer understanding from WHO and other societies that this is a time for interventions and solutions being happening at the scale of few years, not at the scale of decades. And I think that this will be reminded in many other sessions. Thank you very much to my co-chair and to the organizers again, and all you for attending this session. Thank you.